All right. So, hello and welcome to an Flyability webinar. Today we're going to be talking to you all about our brand new surveying payload. Thank you for joining us today. So we've got a great lineup today of speakers. We're going to be hearing from our co-founder and CTO, Adrien Briod, as well as our product manager, Michael Blake. So just so you know how the webinar works, you're able to ask questions during this webinar using the little chats thing on the side. I think this video, yes, perfect, demonstrates it to you now. The questions will come through to us on the organizer side, so they're not going to pop up, and we're the only ones that can see your questions. So ask at any time, and we'll get back to you at the end of the session when we've planned some time to have a Q&A. The webinar is also going to be recorded, so for those that can't attend live today, they'll receive a live recording. And for you who are here and want to perhaps rewatch it or double check some information, you'll also receive an email with the replay within the next 1 to 2 weeks. So what we're going to do is we're going to start off by telling you a bit about Flyability and our mission, as well as our sort of flagship drone, the Elios 3. Then we'll go into the Elios 3 surveying payload, which was launched just this month. After that, we'll also give you a sort of deep dive into the accuracy and analysis of exactly why we think this surveying payload is so special and how it's going to be a bit of a game changer in the market. To get us started, we'll be hearing from Adrien. So Adrien, if you're ready with camera and mic, I think you're good to go. Oh, and you'll have to forgive us today. I'm afraid Mike's camera isn't working because technical difficulties are always timed that way. So you'll have to only cope with Mike's voice.
Thank you, Elo. Thank you for everybody joining us at this webinar. It's really a pleasure to be able to speak about our new surveying payload. I'll start with a quick introduction of Flyability. And, you know, it's been almost day to day, 9 years we started Flyability with Patrick. And we, from the beginning, had this vision to have no more humans do dangerous jobs. And that's really been at the foundation of Flyability. And we really, from then, developed a whole range of products to send robots instead of humans in really hard to reach and dangerous places. So I'm going to share my screen, I believe. I have just...
Yeah, your screen's presented, just put on presenter slideshow.
Okay,
yeah.
okay. Excellent. And we've really, you know, pioneered at Flyability this indoor drone segment. Before us, it was really not possible to have commercial drones able to fly indoors. We've brought a collision-tolerant drone concept to the market in order to easily fly in these places where collisions are almost unavoidable and where you have dust, where you have really no light, wind gusts, etc. Lots of challenges. And we've been, since our beginnings, bringing drones in these areas. And as you will see today, bringing surveying to these areas. Now, originally, we are not from surveying. We are from visual inspection, but I will explain how that is changing right now. And in general, the value proposition of our products are first and foremost to improve safety. When you can avoid having people go in confined spaces or working at height, etc., it's hugely beneficial, of course. Then reducing downtime, especially when you do indoor surveying or indoor inspection, it's often when an asset is down. So fast forwarding such an operation can bring your asset back online faster. And thus, there are lots of savings involved in that. And then lastly, lowering costs. So instead of building scaffolding or sending over multiple days rope access people, doing sometimes a few batteries, a few minutes of flying can get the data you need and really reduce simply capture costs. We've, over the years, reached more than 1,000 customers. We're working across the globe thanks to a large network of resellers, almost 50 of them. We have really a lot of now big names having adopted our products, both asset owners and inspection companies. We are definitely providing value to those who own assets and want to keep them online, or depending on industries, of course, service providers who cater to these asset owners. We really have now matured our products thanks to the sheer amount of drones we've been able to ship to all these customers. More than 2,000 drones made here in Switzerland and shipped across the globe, which have reached probably more than 100,000 flights across the most challenging industries, from chemical to cement, power generation industries, infrastructure and utilities, in particular sewer inspections, etc., in mining, in oil and gas, and so on. There's a wide range of use cases for our products. And we started with Elios 1 in 2016. Really the first collision tolerant indoor drone. Again, before that, it was unheard of to use commercially a drone inside. And we could demonstrate that, in these challenging environments, you can survive collisions with Elios 1 and fly in there with a minimal feature set for inspection, but really proving the concept. Elios 2 was a very strong iteration over Elios 1 to bring visual inspection to more people with more intuitive usage and a step up in reliability. And last year, we released Elios 3, which for us really has been a major paradigm shift because we are, with Elios 3, bringing really a platform to the market, enabling more than just visual inspection. And that's where the Surveying Payload comes in. We have really made Elios 3 capable of taking on various payloads for various use cases. Like I mentioned before, there's really a wide variety of use cases for indoor drones, and we are able now to specialize Elios 3 for different use cases. And we are also on Elios 3 able to bring further software capabilities. So there are all the sensors on board there to make Elios 3 fully autonomous for really all sorts of applications, which will also be shipping with software upgrades down the line. So now, what best than work with really industry veteran, so to say, to bring the Surveying Payload to the world. And so that's how we've decided to partner now for many years with GeoSLAM, which has become part of Faro, in order to bring this capability on Elios 3. The advantage is that GeoSLAM and Faro have really had years and years of experience delivering surveying products to the market. And we've worked with them hand in hand to have our Elios 3 LiDAR able to be processed on the Faro software in order to run their SLAM algorithm, their mapping algorithm, tuned to the right parameters in order to deliver what we call survey grade maps, and also to provide a lot more features that are relevant whenever you're building 3D models and processing them, etc. And so really we are with this payload bringing surveying to new use cases. We know that comprehensive data is key to supporting operational decisions, and today there are just places that are out of reach of terrestrial scanners or mobile scanners, because you cannot just send someone easily, a surveyor, in these spaces. And so there are many hazardous environments that are just not surveyed, even though they could really benefit the project or provide crucial data. For example, in mining, for example, in infrastructure, surveying sewers, or in all sorts of industries where you need really accurate dimensional information, or you need recurring survey to look for changes up in the air, but indoors, etc. And so, with this Surveying Payload, we are including in a package a new hardware for Elios 3, so a new LiDAR that really is available since last month only. We just launched it for Intergeo last month of October. In there is the Faro Connect software. So this is the software developed by the former Geoslam team, now part of Faro, which is really processing the Elios 3 LiDAR scans and IMU data and running the accurate mapping algorithm. In the package, we're including reflective targets. As you will see, there are features in the software that allow for georeferencing or alignment of point clouds based on targets. And we're including a training course in order to have information that allows you to be successful, especially since mapping from a drone is a bit different from other sorts of mapping, especially in confined spaces. In a nutshell, the features of the surveying payload are in the nominal conditions, 0.1% of drift, 6 millimeter of precision at 1 delta, up to 100-meter range. So that's when you have good reflectivity. It can be from 35 meter to 100 meter, depending on the surface reflectivity. 1.3 million points per second. So you can really cover a large space with high density, even at a long range, thanks to the amount of points that is captured by the LiDAR. And the 10x improvement on the photon sensitivity. This is compared to the previous LiDAR or the LiDAR that is shipping, let's say, in the standard Elios 3 package. In terms of accuracy, 0.1% drift, and drift is a metric we use a lot to describe the accuracy, means that after 100 meters of travel from your takeoff location, let's say where you have a very solid, for example, georeferencing or reference, then you get a 10-centimeter error. And we use drift a lot because the use cases involve a lot of surveying in places that are beyond reach. So we might not have control targets within a confined space or beyond the takeoff location. And so knowing how accurate will the model that you capture be, if you, for example, align it around your takeoff location, is really the metric we use the most to describe the accuracy. We've really worked hard to get this accuracy to what we could consider an industry standard in terms of mobile mapping. This is really one of the key focus in our development in order to deliver the surveying payload. And it will be the subject of a whole part of this webinar later presented by Mike. And so with the new surveying payloads, what we're unlocking is a lot more success and accuracy in indoor tunnels. And that's really coming from the extra range and precision and point density of the new LiDAR that we ship with the surveying payload. And that's really opening very interesting use cases, we believe, in all sorts of water management infrastructure or other sort of infrastructure. Then in terms of precision, so here we talk again about the 1 sigma 6 millimeter precision. You can see that it gives really a much more nicer looking point cloud. Also thanks to the point density and photon sensitivity, you can see all of the sort of intensity showing, for example, lines on the ground or more features, as well as the precision showing a lot more details about all sorts of structure that you might have in your model. And the precision means there's a lower wall thickness, etc. And this is another side-by-side. The improved range and point density really means that in one flight, in one battery, you can capture a very large area. So this is an example of what you can capture in 18 minutes of flight time. This is a 340-meter tunnel in an underground mine. And as some of you who are using terrestrial scans know, it would take quite a lot of time to survey such a big asset. And here on the left, you see in 18 minutes or estimates of what you could cover. With the Elios 3 standard configuration, you see in the middle what can be covered, and with the surveying payload on the right side, we can cover it all by just flying also in the center rather than doing closer captures to the walls, thanks to the improved range and point density. So Elios 3 is 48 by 38 centimeters. So we can really bring it to some of the smallest confined spaces. Now, as you will hear later from Mike, there are some restrictions or some extra challenges in mapping really confined spaces. But know that Elios 3 can really access these sort of small sewers or tanks or pipes down to, in general, we say 80 centimeter diameter being sort of the minimal area or section of a pipe that will work. And that really comes from the Elios 3 key capabilities to bounce off obstacles and to handle really difficult confined environments. A bit more about the Faro software. And so it's not only about reaching a high accuracy through the Faro SLAM algorithm, but there are other tools that are important whenever you want to bring your 3D point clouds further. So I mentioned we are shipping targets together with the package, and this allows to use the data alignment or georeferencing workflows on Faro Connect. For example, if you have multiple batteries that give you multiple point clouds, you can bring them all together by aligning them if they see, for example, the same reflective targets. And that's easy to do thanks to the alignment workflow. Or if you repeat a scan, for example, for convergence monitoring, or if you want to do change detection or stockpile monitoring, for example, it's very useful to use the alignment workflow with targets and to always have the same area aligned whenever you do the scans every day or every week and so on, so that you can apply some comparison algorithms or whatnot. There are very also interesting options for point cloud filtering. Typically, you can clean the data sets, etc., and finally export data to various formats, to various other software that Faro is used to interfacing with, etc. So just to clarify a little bit, the difference between the Elios 3 standard package and the Elios 3 surveying payload. This is a table that I think is worth explaining before I hand it over to Mike to look further into the precision and accuracy. So if you go with Elios 3 standard package, you will get already the fly-aware mapping algorithm, which is really our Flyability SLAM engine for localizing inspection data. And it's really real-time SLAM focused on robustness and running on the drone to provide you with a live map while you fly, and on Inspector to build inspection reports. And it's based on the IMU, 3 computer vision cameras, and the LiDAR. On the other hand, if you want to really focus on delivering 3D models, and when that's really what matters, and that's the end result, we really recommend going with the surveying payload and Faro Connect, which allows for further post-processing with Faro SLAM, and also allowing these other workflows that I just mentioned. Important to know is, in order to ensure the high accuracy, Faro is only relying on the IMU and not the computer vision cameras. And of course, you always have access to Elios 3 FlyAware, even of course if you use the surveying payload. And then we have these range point density improvements, light sensitivity improvements. You have to know the LiDAR that comes with the surveying payload is more complex and more advanced and a bit more heavy, and thus you lose a little bit, 30 seconds of flight time with it. And the precision and accuracy is much improved, and that's really the part that will be presented by Mike, our product manager for this product, in the next few slides. Over to you, Mike.
Perfect. All right. Mike, we've got, I think, your camera on now, so which is great. Earlier it wasn't working, and you're presenting nicely. Let's go.
Great, thank you so much, Adrien. That's a really nice explanation of the survey package. What I'd like to focus on next is a little bit more in depth into how we're able to achieve these kind of accuracies, precisions, etc. But first of all, we want to define exactly what accuracy, precision actually means and what it means to when you're actually going to go mapping with the drone itself. So when we look at what accuracy means, accuracy is how accurate you are to, let's say, an absolute planar surface. So you see on the left-hand side here of your screen, how accurate we are. We can be very, very precise to a wall, but we also show that we're accurate to the wall as well. So we can have a little bit of noise, whatever, within the accurate state of the new LiDAR. However, we are accurate to that planar surface. However, when we have points that are sitting off the absolute precise wall itself, then we are what we call basically inaccurate. When it comes to the actual precision itself, we can have very, very nice tight points together, but we may not be actually accurate to that surface or to the absolute of what we want to achieve. So here on the left-hand side, you see that we are very, very precise, but we're actually not accurate in that sense. On the right-hand side, what we have is something that's not very precise, but and also very not accurate as such. So to look at more, let's say in the case of, let's say, a geometrical type of mapping itself, on the top left-hand side, you see that we are quite accurate to the actual ground truth, let's say, or the actual object that we want to map. However, we're not totally precise to it. On the bottom left-hand side, you see that we're both actually not accurate and not precise. Moving over to the right-hand bottom side, we are very precise, however, we're not accurate. So the points are very precise to one another, so the neighbors are quite precise. However, the accuracy is just not there. And what we really want to achieve here is be able to show that we can achieve the accuracy and also precision at all times we're mapping different types of environment. So to go in more into what the global accuracy and the meaning of global accuracy is, you see on the left-hand side of your screen, we have the drone flying into an environment that has small features, geometric features, etc., where the LiDAR can really lock on and get key points from while the drone is flying. On the right-hand side, what we see is we first an object that's very, let's say, smooth or very cylindrical or symmetrical in value, where we sometimes we're able to suffer with LiDAR because we're not able to lock on to geometric features. And this is something we'll go into a little bit more in depth, especially if we go more underground into the sewer networks, etc., where cylindrical and symmetrical values are more common when it comes to LiDAR. So on the left-hand side, you see areas such as indoor objects, such as built-up areas, even some outdoor flying where we can gather really nice sharp key points from. We can get very, very good accuracies with LiDAR, good precision, and also reduce the amount of drift that we accumulate throughout the flight. However, on the right-hand side, we see that we don't have anything to lock onto in LiDAR. However, with the new LiDAR and also FARO, we can try to reduce that much of drift that we can accumulate in these environments as much as possible when we're flying in areas such as symmetrical environments. So one of the environments that we've tested in is a structured environment. So as you can see here in this environment, we have walls, floors, we have electrical conduits, pipes, etc., doorways. So we have a lot of key features that the LiDAR can lock onto, and GeoSLAM has a lot more ability to be able to produce really nice SLAM outputs. So in this case, as Adrien already explained, we're able to achieve between 0.1 to 0.2% of drift over the whole area that we mapped. Compared to that with Elios 3 and Flower that we had before with a standard configuration, we're more in the range of 0.5 to 1% of drift when it comes to this type of structured environment mapping. So to go through how we are actually able to achieve this, what we did was we actually took this structured environment, which is the basement of a factory. We laser scanned everywhere with a Regal scanner. Those of you who are in the survey world will know how precise the type of Regal scanners are. So we're getting plus or minus a couple of millimeters with Regal scanners. This took around, I think, around 15 to 20 scans to be able to cover the whole area. Also, the whole area is covered in targets. So we had up to 15 to 16 targets throughout the whole area. So these targets were actually retroreflective targets that we used to do the tests. From that there, we flew the lidars, so the standard configuration with Elios 3 and also the new survey payload. And what we did is we wanted to compare the Regal data against the standard LiDAR data and also the Rev 7, the new LiDAR data as well with the Elios. So by doing that, as Adrien already said, we have one of the biggest use cases we have for our customers flying the drone is they want to georeference around the takeoff area, because when you're flying to confined spaces, up mine shafts, down to sewers, whatever type of map you're doing, it's the reason why you're flying the drone is actually because you can't access these areas. So it's very hard to georeference these areas unless you can georeference around the takeoff area. So in this case, what we did was we ICP the takeoff areas. So you see on the left-hand side of your screen, on the map section, you see the red area where we took off from and landed from. In this, what we did was we referenced all of the flights that we did with Elios between the standard configuration and also the new LiDAR configuration Rev 7 from Oster to this area. So this was a 15 meter by 50 meter box, and we used that transformation that we got from that and transformed that transformation across all of the data that we got from the flights with the drone. So that if you look at the graph or the box that we got below, you can see with the survey package with Faro Connect and also the Rev 7, we're able to achieve really, really good drift accuracies between 0.16% and also 0.13% on the XY. Comparing that to what we got with the Flyware, which is our onboard SLAM algorithm on the drone, and with the standard configuration LiDAR, we're able to achieve roughly around the 0.5%, so 0.5% to 0.3% of drift factor. So it doesn't sound like much in the long scheme of things. However, when you are flying big longitudinal assets and you accumulate drift over a distance, that can accumulate to centimeters up to meters, depending on what type of environment you're mapping. So to reduce that amount of drift factor we get is a real key factor of what we want to achieve with the new LiDAR. Looking at a cross-section also, well, a vertical cross-section of the furthest away extended point from the takeoff area of the same factory basin that we flew, you can see that we have the Regal data that's in red, and we have the in white, we have the new Rev 7 and Faro process data. And comparing that then to the Rev 6, what we really saw was a really, really big improvement on the Z accuracy. So on the XY, we were actually quite good, but however, on the Z accuracy, between the LiDARs, there's a big difference. And this is really important to a lot of customers. As a lot of you might know, that are in the survey world, the Z accuracy, whether it's a GPS, a total station, or laser scanner, is always quite hard to achieve good accuracies on the Z. So here we're able to get a massive improvement on the Z. On the right-hand side, what you see on the screen is orthographic cross-section throughout the walls, and that demonstrates where the SLAM algorithms are stronger and poorer. So if you look at the Flyware model, you see that we do have some artifacts or collapse of the actual SLAM algorithm itself. So the Regal being the red, and you see in green the Flyware. So you do see that the walls themselves have collapsed together. Even though the Flyware algorithm is quite robust in a lot of environments, it struggles sometimes with the very, very fine detail like this. If you look at the image below with the Faro data and also the Regal data, you can see that it's very, very well reconstructed, the wall sections of planar surfaces, and we're also getting very, very much tighter accuracies with that. So it's kind of just to show basically the difference between the standard setup that you get with the Elios 3 and also the survey package. Going more into the symmetrical environments and the different types of accuracy we'll achieve with the symmetrical environments, we did a lot of tests and really a lot of different types of of symmetrical environments, everything from large tunnels, big storm drains, all the way down to very, very small culverts, brick sewers, trying to, let's say, evaluate all the different types of environments where our customers could be using this payload in. So you see here from a local gallery, actually here in Switzerland, the tunnel itself is more than 2 meters in diameter and it has regular geometric features. So in this case, it's a concrete tunnel. However, we do have pipe structures inside. We have racks inside, etc., to carry these pipe structures. We have electrical conduits, lighting, etc. So in this environment, comparing it to laser scan data that we got previously from surveyors, we're within the 2% of drift factor with Elios 3 and Flyware. However, what we're seeing with the survey package is we can get that drift factor to between 0.25% and 0.5% of drift. So it's a 5 to 10 times improvement over the previous standard package with the Elios 3. Going more into detail of some other tests that we've done as well in regards to symmetrical environment testing. We picked a local storm drain actually here in Lausanne, and we got some laser scan data that was previously done by a Leica scanner, so we know that it's accurate to within 1 or 2 millimeters. And similar to what we did with the basement of the factory, we ICP'd around the start of the sewer section. So you see on the top left-hand side of your screen that we flew the drone a couple of times with the Rev 6 LiDAR, standard configuration, also Rev 7 LiDAR, and we joined all those flights together at the very opening of the sewer. And from then there, what we wanted to monitor was how much drift we accumulated throughout the sewer section itself over a distance. So in this case, we had 200 meters of sewer section. And as you see on the right-hand side, when you look at the ground truth from laser scan data and look at the Rev 7 Faro Connect process data, we're very, very close in tolerance to what we're to get for the ground truth, especially in comparison when you look at the Rev 6 data and Flyware. We accumulated quite large drift factors. So with the Rev 7, we're able to get that down to just under 0.2% of drift over 200 meters in a symmetrical environment, which is really, really a good result and what we're really hoping for in this package. If you compare that then to the Rev 6 and also Flyware, we're up around the 1.4 to 1.5% of drift factor. So definitely when it comes to these types of symmetrical environments, flying underground and sewers, pipes, etc., there's definitely a huge advantage, especially on the drift factor when it comes to the survey package. Slide. Next, we start to test a little bit more in the challenging types of environments. So still tunnels and shafts with light geometric features. So in this case, as you see, it's another tunnel section that we flew. However, it just has a slight concrete, shotcrete finish inside with a smooth concrete surface and path and drainage network. This again is 2 meters in size. However, absolutely dead straight with just a very, very slight slope angle. So for the SLAM algorithm to be able to process this data into a nice accurate model, it's a little bit more challenging. However, in this case, when we looked at Flyware and the standard configuration, we're getting that's 2 to 5% of drift factor, so quite a bit more of drift factor. However, when we looked at the data that we achieved from the survey payload itself, we're really far tighter compared to what we get with the standard configuration. So with the survey payloads, we're getting that 0.5 to 2% of drift in these types of symmetrical environments that are really, really hard for the SLAM algorithm to lock onto any features to be able to produce or to correct that drift factor. Next was actually quite a challenging environment that we flew. So this was a brick line sewer built back in the early, I think, 1900s or so, underneath the city, where they wanted to reline the sewer network itself. So the goal with this was to be able to map as much as we could inside the sewer. So the sewer itself was under 2 meters in size. It was actually 0.8 meters across and 1.2 meters in height. So very, very challenging to fly inside. However, the Elios had no problem to be able to fly inside this area. The main outcome for this was they wanted to produce a nice 3D model of the sewer itself to do orthographic cross sections through every 1 meter. And they want to reline the whole sewer, and they have a machine that goes inside called a GPR system that will reline the sewer itself. However, they need good, accurate models of the sewer itself, especially from a cross-sectional awareness point of view, to be able to know if there's any pipes coming in, if the diameter changes, etc. So in this case, it had very, very light geometrical features inside. It did have a small trough where it was carrying the water. It had some pipes coming in as well and some branches off, but in this case, it was a quite challenging environment to fly and map. With the Elios standard configuration, as you'll see in the next slide, we got quite a bit drift factor. It wasn't any data that was actually usable at all from the standard configurations. We had 5% plus drift factor. However, with the survey payloads, we're able to get that drift factor to within 2 to 5% of drift factor. So a twofold improvement to what we were able to get previously with the standard configuration. As you see here, a little bit more or better. This is across the side view of the overall sewer that we're able to achieve. So this was achieved in one flight actually. So this is 120 meters of flying inside a 0.8 by 1.2 cross-section sewer. So very, very tight, a tight area to fly in. And as you see on the bottom, you see the difference between the faro being in the yellow color and also the flyover being of a good blue color. So in this case, we had quite a large drift inside this very, very narrow and long asset compared to what we're able to achieve with the faro and also with the new LiDAR, be able to correct a lot of that drift factor as much as possible and be able to achieve the types of outputs our customers are looking for. Just to touch base on also some of the things that we're able to achieve using the Faro Connect as well. Here is a model of actually a riser in a mine that we flew, and you see on the walls themselves the targets in place. I think Adrien already touched base on this with the target workflow. So this is looking a bit more into how we achieve these types of accuracies as well when it comes to everyday type of mapping. So here our customer wanted to fly this riser section. We attached the targets onto the walls before we went into the riser and flew up into it. And then we georeferenced all of those targets using a total station that was already georeferenced. So in this case, we had 7 targets in total. We, within Faro Connect itself, because the targets are a certain size, 200 millimeters, and have a diamond reflective surface, Faro Connect will automatically detect the centroid of those targets. Then all you need to do is bring in your XYZ file for your total station into Faro Connect, and all of the magic within Faro Connect will georeference the flights to those total station points themselves. So there's no need to manually try and align the point cloud to targets. Then to targets to the data from the total station. It's all done automatically within Faro, so there's no guesswork at all. As you can see down the bottom right-hand side, if you look at the average RSM error that we're able to get here, in this case, with the targets laid out at the start of this riser and flown into the riser, we're able to achieve 90 millimeters overall accuracy using the Faro Connect also combined with the survey payloads as well. So really, really good accuracies and the type of survey grade accuracies our customers are looking to achieve day in, day out. Also some types of applications as well that we're looking more into with the survey payload is outdoor flying and also mapping big infrastructure. So you see here, this is a bridge that was captured actually by a reseller drop price in Belgium, and this is a live road network that was operational at the time of flight. Here it was actually 4 flights combined into one. So within Faro Connect, you're able to take those individual point clouds and either merge them by 2 means, by manual means, so you can merge the point clouds manually, end on by end on in this case, and then there's a final alignment workflow that will finally align those point clouds together and reduce any of the drift factor to give you a nice model. Also, if you have targets placed out, so the same diamond reflective targets that you can use for georeferencing, you can also use those targets as well to align all the point clouds together. So in this case, if you want to place targets all around the bridge sections, you can use those targets to align all of the point clouds together automatically in Faro Connect. So it takes the guesswork and the amount of time and patience needed to be able to align all those point clouds together. And another fun application that we're looking into more and more are forestry mapping for biomass calculation, also crown monetization, calculating tree stumps, tree yields, etc. So traditionally drones could never fly around through the trees, etc. to do LiDAR mapping. They always have to fly above the trees, so you have to fly quite a larger quadcopter or fixed wing to do this type of mapping. Now we can actually fly within the tree networks themselves. and get really, really nice high dense point clouds with using the survey grade payload. The extra range, as Adrien said, really helps to be able to capture these types of environments. As you see here, we can also pick up the cable car and also surrounding buildings, houses, etc. This was, I believe, 3 or 4 flights. I think 3 flights, all merged together within processed and merged together within Faro, and then a slight filtering put over it too, to produce a really, really nice, clean point cloud model. Yeah, just to finish up and review everything that we've gone through already. So on the hardware side, we have now the survey payload with LiDAR delivering the Elios, delivered with the Elios 3. We also have Faro Connect, so the adaptation from GeoSLAM now to Faro, which offers us to be able to use their SLAM algorithm to produce a really nice high dense point clouds, which are precise, accurate. We can also do all the georeferencing within Faro Connect. We can also do all the merging of point clouds, whether it's with the targets or whether it's manually using their fine alignment workflow. We can also add filters on top of that too, to filter out any of the data that we don't need or any noise that we get, depending on the type of environment we're flying. Also, plus that, we're also reselling targets too. So if you're looking for the specific SLAM-based targets that we use for these tests, we also resell those in packs of 6. And lastly, we also provide training course as well, online training course of 6 modules, sorry, that will go through all the steps of flying the drone, capturing data, how to do the correct survey flights in different types of environments, bring all that data then into Faro Connect, process that, filter that, register that data, and be able to produce the output that all of our customers are looking for.
All right, amazing.
I'll hand it back to you.
Yep, thanks very much, Mike. I'll leave the presenting on your screen for now, if that's okay with you. So now we've actually got some time for questions. So very well timed to our 2 presenters. Thank you. The first question I have is, I suppose this would probably be best, well, either of you could answer this, I imagine. The question is, do we have any drawbacks to the new payload for inspection-focused flights, apart from the battery, or does it do everything that the original payload did, plus some new benefits?
I can quickly take it. It's indeed a very good question. There is indeed so the flight time that's already mentioned. I would say there's a little bit more data that is generated as well. So that means you'll have to empty the drone onboard storage a little bit faster, but I would say the laser scan files will probably double in size, but you know, the camera RGB data will not change, and the rest of the logging data will not change. So it's probably a 20–30% increase in file size per flight. And then I would say to process data with the new LiDAR on Faro Connect, you will need a good computer with recommendation is at least 64 GB of RAM. So however, if you only want to use Elios 3 with the Surveying Payload as an inspection tool, you don't need to process on Faro Connect, and thus this is only a requirement for doing further processing. Well, it's more costly, so that's of course to take into consideration. You'll probably, of course, want to make sure you have a return on investment for your projects where you are required to deliver this sort of accuracy. Yeah, that's about it.
Yeah, perfect. Mike, do you have anything to add there?
No, I think Adrien covered it very well.
Yeah, perfect. All right, so then next question is about the vision sensors. Are we still using, are the vision sensors still active for flight stability, or are we only relying on the LiDAR payload now?
So in any case, for FlyAware, with or without the Surveying Payload, the 3 computer vision cameras and the LiDAR and the IMU are always merged together to provide onboard stability. When an environment is dark or dusty, for example, the SLAM will really mostly use the LiDAR data. If it's very symmetric and the LiDAR struggles, it will put more weight on the cameras, etc. That's also going to provide the live map and the inspector map for building reports. And that's always the case. And then if you opt for the surveying payload, well, you'll have the benefits we just discussed, and you'll be able to bring the processing further with Faro Connect.
Perfect, thanks. So we've had a question from someone who says, we've already got several Elios 3 drones. What upgrades or software platforms do we need to utilize the new surveying payload?
So if you've already purchased the former surveying package, which was basically the JustLam Connect license, you can upgrade with a trade-in for the new hardware, and you will also get, if you have a perpetual license for JustLam Connect, the option to upgrade JustLam Connect to Faro Connect. If you're within 1 year, otherwise there's just a small maintenance fee to pay to keep access to the upgrades. If you have an annual license, you'll just have to renew your license, or if you're still under the annual license, you'll automatically get access to Faro Connect. And we have a trade-in program where you can ship back the old LiDAR to exchange it for the new one. And if you prefer it to have both LiDARs, you can just buy the new LiDAR as well.
Mm-hmm. All right, perfect. Mike, I think this is a question for you. Can you do volume measurements for stockpiles with this new payload?
Yes, absolutely. It's one of our key use cases also that we didn't actually touch here, but for volumetric calculations, especially in hard to reach areas where there's an actual finished stockpile in a plant, or you're doing volumetric underground inside a stope in a mine, it's a really good tool for using that. What we're seeing also with the survey grade payload is that we're getting very, very, very good accuracies with the payloads. We've done some tests locally with the plant, and where we flew their stockpile hole up to 7 or 8 times, and also compared that data to terrestrial survey graded data that they got from laser scanner, and we're actually under 1% of volume difference between the drone and also the terrestrial data. So yeah, it's a really key use case for the drone that's actually growing quite a lot, because some of these stockpile areas, stockpile holes are very, very dusty, and it can be quite dangerous to get humans inside to do this type of surveying. So yeah, really good use case for the drone.
Perfect, thank you very much. So the next question is about what's the impact of homogeneous surfaces on the new surveying payload. Mike, I was going to say, maybe do you want to flip back a couple of slides, because I think one of the slides dealt with this a little bit, and we can go over that. Yeah, I think
this
around
is probably
here.
the right slide or so. So yeah, in terms of the homogeneous surface data, it does affect the LiDAR accuracy a little bit, especially in terms of the drift factor. So in this type of environment where the diameter is 2 meters or even smaller than 2 meters as well, with very, very light geometric features. So really there's no manholes, no structures inside, no pipe racks, nothing. So really just a smooth surface, or quite smooth surface. We do suffer a little bit from the drift factor compared to the structured environments. In this case, when we looked at the standard configuration with Flyware, we are within the 2 to 5% of drift, so quite a lot of drift, especially over a given distance. However, with the survey payloads, we can get that drift factor down to between 0.5 to 2% of drift factor, but that really depends on the type of environment you're flying. So if the environment has a little bit more features or has surface texture, that will really help to improve the SLAM algorithm in terms of the drift. However, if it's a very, very smooth, like concrete pipe, etc., or concrete finish, sometimes it can be a little bit different. So that's why we put a little bit more difference on the drift factor in this environment with the survey payload, because it really depends on the type of environment that you're flying.
All right, thanks very much. Just a note to our attendees, so we've got a couple more minutes for questions. We've still got a few, but if you have any that you haven't submitted yet, now's the time. Our next question is actually, I think, a product development question. So it's, will there be automatic navigation and coming back to the starting point?
So like I mentioned, Elios 3 is ready for full automation. And so the short answer is yes. I don't have specifics about the timeline and what feature will come first, but we absolutely know automation is an important feature, and there are many sort of sub features like return to home that will really help. And we are definitely working on this. We had already actually before the launch of Elios 3 a lot of experience with autonomous drones. We took part in the DARPA Sub-T challenge a few years back, which really helped us shape Elios 3 to be automation ready. And so yeah, there's not a lot more I can say right now, but that's absolutely on the roadmap.
Yeah. Thanks, Adrien. So, Mike, we've got a question asking about the accuracy of the bridge, or talking a bit, like giving us some more details about the bridge project.
Yeah, so the bridge project actually was done by our reseller in Belgium. It was a live bridge. The bridge's structure itself was over 600 meters of length, and it was broken into 4 flights. So two of the flights was really focused around the main bridge section, which opens up actually. So they did 2 flights around there. And the bridge sections going to left and right of that, or north and east, were broken into 2 different flights as well. And all that area, that data was merged together. They did actually place some checkpoints on the ground as well. So some retroflected targets on the ground, and those targets were GPSed into positions. So the accuracy to that was around 5 to 10 centimeters of accuracy to the GPS positions on the ground. So, but however, the precision of the bridge itself is very, very tolerable as well. One of the key things about the flight too was with Elios, they're able to fly in and around between each of the columns of the bridge below the bridge deck itself. And then because the bridge was live, they weren't allowed to fly above the actual deck itself. However, by flying the drone longitudinally along the bridge deck itself, they were able to capture some of the top of the bridge deck. However, because of regulatory reasons, and also because it's a live bridge, there was traffic on the bridge, etc., they weren't allowed to be able to fly directly over top of the bridge. However, with the new payload and also the extra range and density, they were able to capture areas of the top of the deck of the bridge. However, the main goal was to be able to capture all the column area, all the vegetation below. There's also a river system and dike system underneath the bridge that they wanted to capture too. So the main goal was to capture the bottom of the bridge and all the surrounding areas. However, with the extra range and LiDAR, they're able to capture the top of the deck as well. When it comes to merging the flights together, you need around 10 to 15% to manually merge the flights together. If you're not using target workflow, if you're using target workflow, you do need less overlap. However, it is nice to keep at least 5% of overlap, so the points are nicely aligned when it comes from flight to flight. But yeah, the model itself, it was very, very nice, I have to say. The precision was very, very good. So the accuracy was also good, depending on the type of targets and layouts. And probably the future is good to probably place for a few more targets in place, and also georeference those targets, maybe placing targets on the actual structure of the bridge itself. However, the model itself came out very well, and within 4 flights, it's a very, very large area to cover within 4 flights. And that's thanks really to the extra range and density of the survey package that we're able to really capture these types of environments now. So yeah.
Yeah, perfect. Thank you very much. So the next question is, we've got actually a couple coming in now, so we've got a few more minutes. Let's go with this one. So the processing for the new LiDAR at Faro, is that completely different from what's currently in use, or has it got any similarities?
I guess the question is versus the current GeoSLAM Connect, right?
Correct. Yeah.
Yeah.
Go ahead, Mike.
Yeah. So actually, let's say the processing itself is quite similar to what was with GeoSLAM Connect. However, the UI has changed slightly. It's actually become there's more fluidity within the processing itself. The main upgrade as well is the algorithm itself is now 30% faster compared to what it was with the GeoSLAM Connect. So we have the added advantage of having a faster SLAM algorithm. Also, for symmetrical environments, also the robustness of the new SLAM algorithm seems to have improved massively as well. So to be able to achieve really good accuracies in symmetrical environments, that's a really key factor to have the new SLAM algorithm. Also registration too, registration meaning registration to targets, so bringing in the target workflow. It's also far more robust than what it was before. So yeah, so overall, there is quite a few improvements, and also more improvements to come as well with Faro Connect into the future.
Mm-hmm. Thank you. The next question is a good question, one we like, is basically, is the payload available for shipping now, or is there more of a wait time?
Yeah, it's shipping actually this month. We've already shipped the first units, and a big batch is shipping this month, and yeah, standard lead times to be expected. Yeah.
Perfect. But that means people can order one now if they'd like. So, the next question is, do we have any upgrades in the thermal camera? So not necessarily to do the LiDAR payload.
No, at the moment, yeah, Elios 3 remains for the whole platform as it is. It's really only the LiDAR that is swapped with this product. There are going to be other developments on a roadmap, but nothing right now about the thermal camera to be announced, no.
Perfect. Actually, that's worth just sort of mentioning again for anyone who doesn't already know. One of the joys of the Elios 3 drone is that it's got a modular payload base, so you can actually swap between which payload you have. So this is our LiDAR payload. We also have a radiation detection payload, and it's a way for the drone to keep being developed without having to always get a new drone. So I'm just checking. So there was a question, is there a cost estimate for the LiDAR product upgrade? So for someone who already has the Elios 3 moving to the new one.
We recommend talking to our sales representatives to understand exactly what sort of a setup you currently have and what exactly the offer needs to be. But yeah, everything is available as soon as you get in touch with our sales commercial team.
Perfect. All right. I think that's all we've got time for. We've answered, I think, almost every question, so that was quite good. If you have any further questions, you can always get in touch with us either on our social media or you can email communication@flyability.com. You will receive a recording of this webinar as well, and you can, as we say, get in touch anytime. You'll receive an email with a recording, so you can also reply to that. And I think that's it for now. So Adrien and Mike, thank you both very much for your time today. And thank you to all the attendees as well.
Thanks everyone for attending.
Thanks everyone.
All right. Goodbye. Have a good day, guys.